Hey guys, welcome to the start of Unit 2. We're going to begin with dealing with a little bit with quadratics and doing a quick review today of quadratic functions and all that fun stuff, and then you're going to practice it by taking our notes and putting them into good use for our homework tonight. So hopefully your Unit 1 test is going well. I know that one or two of you have already finished it and turned it in. A couple of you are still working, and I'm assuming most of you are still working through it. So, anyway, hopefully you have printed out the blank notes, and we are going to go ahead and go through them. There's 4 pages of them, so this might be a lengthy little video. Okay. So as you can see from your notes, it says the standard form of a quadratic function is given by f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. A cannot equal 0, because if a equals 0, then you all of a sudden you have a linear function. Okay. The vertex of the equation can be found rather straightforward. Okay. We talked about this as a little shortcut, but remember that the vertex, if you have it in standard form, is just simply the opposite of b over 2a, and then it's f of the opposite of b over 2a. And what do I mean by f of? Well, basically, whenever you find your fraction or your number for negative opposite of b over 2a, all you have to do is take that number and plug it back into the original formula, or into the original equation, and that will give you the vertex this way. Okay? And this is an ordered pair, the opposite of b over 2a and f of the opposite of b over 2a. Okay? Now, as you can see, it says the vertex form of a quadratic function is given by f of x equals a times x minus h squared plus k, where hk is the vertex, and a is, your vertical stretch or shrink or whatever the case may be, and things like that. Okay? So let's look at f of x equals x squared. Okay? So if f of x equals x squared, go ahead and write that function down. This is our parent function. We've already talked about this parent function. Okay, we have the graph. If we plug in 0, okay, we get the point 0, 0. If we plug in 1, we get the point 1, 1. If we plug in 2, we get the point 2, 4. Plug in negative 1, we get negative 1, 1, and of course we get 2, 4. So as you all know, this makes the parabola that opens up. So this is the basic easy peasy function of a quadratic. Now, as a reminder, because it's a parabola, we have the x squared function, there is a line of symmetry. In this case, in the parent function, the axis of symmetry, line of symmetry, we'll call it the axis of symmetry to be precise. The axis of symmetry goes through the origin at 0, 0, and basically it creates a mirror-like object where everything on the right-hand side is the same distance from the axis as everything on the left-hand side is, or vice versa. Okay? As you probably already know from listening, if you've been listening, graphs with quadratic functions are called parabolas. So that first blank in there, you just write parabola. Easy enough. Okay. If a, okay, remember what it looks like. Okay. If a is positive, so in other words, if it's in standard form, the number in front of the x squared, if that's positive, then it's going to open up. Or it's going to be known as concave up. A plus gives you concave up. because it opens up. So if a is negative, no matter what form the equation's in, if a is negative, then you're going to have concave down because it opens down. So concavity in a parabola is actually really, really easy. You just look at A. If it's positive, it's up. If it's negative, it's down. Okay. The axis of symmetry is the vertical line that divides a parabola into mirror images. The equation for the axis of symmetry is x equals negative b over 2a. Hey, doesn't that sound familiar? That's this right up here, right? X equals negative b over 2a. So if you do negative b over 2a, you find the equation of the axis of symmetry. So x equals the opposite of b. I keep saying negative. It should be the opposite of b over 2a. Okay? And of course, the equation of vertical lines are always in the form x equals something. Okay? All right, so let's deal with the vertex. Okay? You already see on your notes what the vertex form of a quadratic function is. Okay? So let's go ahead and substitute x back into the equation and solve for y. So we have q of x is equal to x squared minus 6x plus 8. Well, a equals 1, b equals negative 6, and c equals 8. All right? So what is the, so this is in standard form. So how can I find the vertex? Well, remember, the axis of symmetry goes through the vertex. So the x value of the axis of symmetry is the x value of the vertex. So basically, if we say x equals the opposite of b over a, well, that would be the opposite of negative 6 over 1, which comes down to be 6. So whatever the y turns out to be, this value of x is really important. Not only is it x equals 6, my axis of symmetry, that's also the x value of my vertex. Okay? So now how do I find the y value? Well, I plug 6 back in for x. So I find q of 6. Well, that's simple. That's 6 squared minus 6 times 6 plus 8. Well, in this case, I've got 36 minus 36 plus 8. That's easy enough. That's 8. So my vertex, finding it from a standard form equation, is just simply 6, 8. Okay? That's actually the harder part. Oops, I messed up. Instead of a, this should be what? This should be 2a. If that's 2a, then that's a 2. So I messed up big time here, didn't I? It's not 6, is it? Okay, so I'm going to do some erasing. All right, so 2 times 1 is 2. Oops. Times 1. So this actually ends up being negative or positive 3, right? So we're going to change that to 3. And instead of trying to find q of 6 anymore, see, I'm human too. It's been a bad morning. All right. So we're going to find q of 3. Still should be pretty straightforward. That's going to be 3 squared minus 6 times 3 plus 8. So 3 squared is 9 minus 18 plus 8. And that comes out to be negative 1. So if I actually write my formula right and plug things in correctly, the vertex from this standard form equation is going to be 3, negative 1. So just remember, it's the opposite of b over 2a, not the opposite of b over a. You know, my b. Okay. Identify the vertex of m of x equals the opposite of x minus 1 squared plus 4. Notice in this equation that a is going to be less than 0, so if we were to actually graph this particular function, you should find that it will open downwards, okay? But we're not going to take the time to graph it right now. We're just worried about the vertex. So if I have this function, m of x equals the opposite of x minus 1 squared plus 4, this is h, this is k. My vertex is hk. There's a reason they call this vertex form. It's because the vertex is staring at you. It's saying, look at me, I am the vertex. Please, please, make sure that you pay attention to me. Okay? So, just like every other function, this vertex, if this says minus 1, that's what I want, so it's 1, comma, 4. So the vertex of this function is going to be at 1, 4, okay? The concavity is going to be down, because it's opening down, because a was negative, and this 1, 4 point is actually a maximum, not a minimum. All right? So, well, what happens if we have to do our friend completing the square? Okay, so in some instances, you're going to be asked to go from the standard form of the equation and give me the vertex form of the equation. And you do this by doing what everybody loves doing, and that's completing a square. So let's go ahead and do the first problem that's written there for you together. So we have f of x is equal to x squared minus 6x plus 8. First thing we want to do is we want to move this 8 to the other side. So I'm just going to keep it f of x minus 8 is equal to x squared minus 6x. Now I can make a perfect square trinomial on the right hand side. So what am I going to add? Well, what's half of this? It's negative 3. Negative 3 squared is 9. So I'm going to add 9 to both sides. So I have f of x minus 8 plus 9 equals x squared minus 6x plus 9. Alright, so this simplifies to f of x plus 1 is equal to x minus 3 squared. And the last step, subtract 1, we get f of x is equal to x minus 3 squared minus 1. Holy cow, we just transformed it, didn't we? We just went from standard form to vertex form. So the vertex of this particular problem is just simply 3, negative 1. And we could prove that by plugging in, we could prove it by doing the opposite of a over b, but I'll leave that to you, over 2, the opposite of b over 2a, but I'll leave that for you guys to do. Okay, first off, a is positive, so the concavity is going to be up, okay? So at this vertex point of 3, negative 1, I'm going to have a minimum of y equals negative 1. And where is my axis of symmetry? The equation of the axis of symmetry is just simply x equals 3 because it's always the x value of my vertex. Okay. So let's do another one. Let's do h of x. Let's do number 2 that's on your notes. H of x equals x squared minus 2x minus 5. First step is to move that 5. So I'm going to have h of x plus 5 equals x squared minus 2x. So then I have h of x plus 5. Well, negative 2 is negative 1. Negative 1 squared is 1. So I'm going to have, look, I already wrote it down. I'm going to have 5 plus 1 is equal to x squared minus 2x plus 1. So now I have h of x plus 6 is equal to x minus 1 squared. So I get h of x equals x minus 1 squared minus 6. Okay, so where is my vertex? Well, my vertex is going to be 1, negative 6. Okay. What's my concavity? Well, A is positive, so it's concave up. Concavity is up. Okay. The axis of symmetry. Axis is x equals 1. Okay. So again, I'm going to have a minimum at y equals negative 6. All right. Okay. What do you think? Not so bad, right? There's a lot of things that you can tell from vertex form, and it's not that bad to go from standard form to vertex form until you do something like number 3. So let's go ahead and do number 3. Number 3, and as it says on there, it has a little bit more to it. So let me write the problem down. G of x equals negative 4x squared minus 12x plus 8. Okay. The first thing you're going to do is take everything and divide by that common factor. Okay. That common factor is negative 4 because that's what we'd be able to pull out of all of this. Okay. So g of x over negative 4 is equal to negative 4. I'm pulling it out first. Okay. Plus 3x minus 2 all over negative 4. Okay, so g of x divided by negative 4 is equal to x squared plus 3x minus 2. Okay, so let's move that 2 over here. So we've got g of x over negative 4 plus 2 is equal to x squared plus 3x. Okay, let's complete our square. It's x squared plus 3x. Now, half of 3 is 3 over 2. 3 over 2 squared is 9 over 4, so I'm going to add 9 over 4. And I'm going to have that over here too, so I have g of x over negative 4 plus 2 plus 9 over 4. Okay. So we come back up to the top. I now have g of x over negative 4 plus 9/4 plus 2. Okay. Well, 2 is 8/4, so 9/4 plus 8/4 is 17/4. And that is equal to x plus 3 over 2 squared. Okay. So g of x over negative 4 is going to equal y plus 3 over 2 squared minus 17/4. So again, it's just being practical, knowing that you guys can actually add, subtract, multiply, and divide by with fractions. Okay. Now, we don't want g of x over negative 4. We want what? We want g of x by itself. So we multiply now by 4. So g of x, or by negative 4. So g of x equals negative 4 times this whole thing, y plus 3/2 squared. But we also multiply negative 4 by negative 17 over 4, and we end up with plus 17. All right. So, where now that I have g of x, where is my vertex? Well, my vertex is going to be at negative 3 over 2 comma 17. My axis of symmetry is going to be at x equals negative 3 halves. Okay, my concavity is down because a, which happens to be negative 4, is negative. Okay? So, hopefully that makes sense to you guys. All right? Now, talking about zeros of a quadratic function. Okay, there's 3 different possibilities for zeros of a quadratic function, and it all has to do with the number of times the quadratic function crosses the x-axis. Obviously, if it crosses the x-axis twice, you have 2 zeros. Okay, so in the first graph, we're going to draw something like this. This is some quadratic function. Okay, it has 2 zeros because it crosses the x-axis twice, and so it would have 2 real roots. Remember, roots and zeros are the same thing. All right. Now, there is a possibility that the graph could just simply come down and touch and turn back around. That's supposed to be touching. Let's draw a better graph. Come down and touch, and then go back up. In that case, we only have 1 zero right where it touches. Okay, it is a double root, but it's real, so it's a real double root. Okay, and an example of this might be something like y equals x minus 2 squared. Okay, this point would be the point 2, 0. There's nothing over here. So obviously if we have 2 zeros and they're both real, we have 1 0 and it's kind of a double root, and you'll see why it's a double root a little bit later. Not today, but a little bit later. The last possibility is to have 0 roots. So in that case, you have a function that clearly does not cross the x-axis at all. So in this case, we would have no zeros. And instead of real roots, since it doesn't cross the x-axis, we actually still have 2 roots, but it's 2 imaginary roots. And remember what we discovered a little while ago at the beginning of the year, that the number of roots of quadratic is always 2. Okay, it'll have either 2 real roots, 2 imaginary roots, or 1 double root. Okay, and by double root, then 1 times 2 is 2. Okay, an example of this would be, remember we have the square root of negative 1, a plus bi, etc. Okay. All right. Now, your notes say that you only have 3 options when you're trying to find the zeros of a quadratic function, but actually you have 4. Okay. Your first option is to graph it. Use Desmos, whatever, and it'll basically do the work for you. Your second option is to factor, and that works really nicely if you have a factorable equation. Your third option, okay, would be to complete the square. And your last option would be to use the quadratic formula. And for those of you that don't remember, the quadratic formula will tell you your zeros, because x is the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. That is something that, if you're going to go anywhere that has any sort of math involved with it, you're going to have to memorize it. So if you don't have it memorized yet, get it memorized. Okay? So, we have some functions that we need to find the zeros of. We are given w of x is equal to 2x squared minus 6x plus 1. Well, we've done a couple of things already. Let's go ahead and use the quadratic formula. If we use the quadratic formula, x is going to be equal to 6 plus or minus the square root of negative 6 squared minus 4 times 2 times 1 all over 4, which is going to be 6 plus or minus the square root of 36 minus 8 over 4, which gives me 6 plus or minus the square root of 24 over 4. The square root of 24 can be simplified. Not 24. What am I doing? That's 28. I subtracted 12. The square root of 28 can still be simplified too. Okay? So that gives me 6 plus or minus 2 root 7. If you're not sure how I got that, talk to me. Okay? Divided by 4. Okay? So that means that all of this can be simplified to 3 over 2 plus or minus the square root of 7 over 2. Okay? So my one root is 3 halves plus the square root of 7 over 2. My other root is 3 halves minus the square root of 7 over 2. Obviously, that's not really a easy thing to, easy number to come up with, right? So, but those are my zeros. I found my 2 zeros. They're both real. They just aren't easy. Okay, so what if I have this? P of x equals 3x squared minus 27. Well, this is a factor thing to me, guys. Remember, we want the zeros, so we're going to make this 0 is equal to 3 times x squared minus 9. We're going to have 0 equals 3 times x minus 3 times x plus 3. All right. So we're going to divide that 3 out. I'm going to divide by 3, divide by 3. We get 0 equals x minus 3, x plus 3. So our 2 zeros in this case are x equals 3 and x equals negative 3. Okay, so let's do number 3. Let's put it all together, sketch a graph of a parabola. F of x equals negative x squared plus 2x plus 5. So in that case, I'm going to say that a equals negative 1, b equals 2, c equals 5. So let's find our axis of symmetry first. I'm going to draw a general graph over here. You've got a nice little graph on your paper. Okay. But I'm going to draw just a general graph so that we can do things as we go along. Okay. So if I know that a equals -1, b equals 2, and c equals 5, I'm going to find the axis of symmetry first. X equals the opposite of b over 2a. So that's going to be -2 divided by -2, which equals 1. So my axis of symmetry is going to be right along x equals 1. Okay. My vertex, well, I need the y value here, so let's put that back in. So I've got my original function of -x², so I've got -1 squared plus 2 times 1 plus 5. Well, 1 squared is 1, so, and then I take the opposite of that, so it's -1 plus 2 plus 5. Well, 2 plus 5 is 7, that gives me 6. So my vertex is going to be the point 1, 6. So here's 1, and here's 6. So there's my vertex. What do I already know about this based upon my original equation of -x²? Okay. Well, my -x² tells me that this is going to open down. So I have a maximum right up there. So that's a good thing that it's like up at the top of my picture. Okay, so how do I find my x-intercepts? Well, my x-intercepts are pretty straightforward. Okay, I'm going to use, since I have a -1 and all that fun stuff, I'm going to use the quadratic formula. So I have x equals the opposite of b, which is -2, plus or minus the square root of b squared, which is 4, minus 4 times -1 times 5, all over -2. So that gives me -2 plus or minus the square root of 4. So -4 times -1 times 5 is 20. So 4 plus 20, all over -2, which equals -2 plus or minus the square root of 24 over -2, which is -2 plus or minus 2 root 6 all over -2. Okay. So my x-intercepts, okay, I'm going to erase a couple things up here. Okay, my x-intercepts are going to end up being 1 plus 1 plus the square root of 6 and 1 minus the square root of 6. Now that's difficult to actually graph, right? So we're just going to have a little bit of a guess here. So let me redraw my graph here. The square root of 6 is going to be somewhere between 2 and 3, so I'm adding a number 1 plus or minus the square root, or something between 2 and 3. So if I add, so it should be somewhere around here, 1 plus, and the other one should be between like -1 and -2. So those are my x-intercepts. Okay, what's my y-intercept? Well, my y-intercept is just simply the function when x equals 0. My y-intercept equals c. Well, what was c? C was 5, so it's 5. So I have a point at 0, 5. Okay. Now, because I also have symmetry, okay, since I have a y-intercept of 0, 5, I also have a point at 2, 5. Okay. Now, how many points do I have? 1, 2, 3, 4, 5. Once I get 5 accurate points, I can go ahead and draw my graph. Okay. You have a much better graph than I do. So we need a minimum of 5 points to draw graph. Okay. Now because our intercepts are not the greatest intercepts, we can certainly plug in some numbers. If we plug in 2, we happen to get 5, which we already knew. Okay, that also goes with 0, 5. It goes with 1, 6. If we plugged in the value of 3, we should get a value that's a little bit negative. Okay, so let's plug that 3 in. So that's negative 9 plus 6 plus 5. Okay, negative 9 plus 6 plus 5 is what? 2. So we have a point. I'm sorry, it shouldn't be negative. Yeah, 1, 2, 3. That's to the left of this. So 3, 2. And then we should have negative 1, 2 as well. Okay. All right. Let's finish this up. If I give you a vertex form and I want the equation of the quadratic, it's really straightforward. Okay. I give you a vertex negative 3, 2, and it goes through 0, 5. Well, guys, plug it in. Okay. So remember, f of x equals a times x minus h squared plus k. And if our vertex is at negative 3, 2, and a point is 0, 5, well, the 5 is my y value. So 5 equals 0, not 0, that's a, times 0 minus negative 3, which becomes plus 3 squared, plus 2. So 5 equals a times 9 plus 2. 3 equals 9a. So a equals 1/3. So then my equation is just simply f of x equals 1/3 times x plus 3 squared plus 2. So in general, if you have a point and the vertex, hey look, point slope form again. You just need to solve for a. Once you solve for a, you take the point out and leave the vertex in. That's all there is to that. Okay. All right, now we have some application. Katniss's arrow follows a parabolic path. The height of the arrow, f of x in feet, can be modeled by the equation f of x equals negative 0.005x squared plus 2x plus 5, where x is the arrow's horizontal distance in feet. What is the maximum height of the arrow and how far from its release does this occur? Okay, guys, the maximum height is the what? The maximum height is the y value of the vertex. Okay? And how far from its release does this occur? Well, that would be the x value of the vertex, because the release is going to be at 0, 0. Okay? Well, almost 0, 0. So basically, all you have to do is find the vertex to answer question A. So let's find our vertex. Okay? It is the opposite of B over 2A. Okay, so I have negative 2 divided by 2 times negative 0.005. Well, the negatives are going to cancel out. this is going to end up being 0.01. What's 2 divided by 0.01? Well, that's 200. Okay? That's the x value of the vertex. That's the second part of that. How far from the release does it occur? Now the max height would be f of 200. Okay? The biggest thing that you've got to get into your head with these things, guys, is if I'm asking you for a maximum height, I'm asking you for the vertex. I'm asking for the y value of the vertex. That's all you got to do. All right, so what do we got to do? We got to plug in that 200, so we get negative 0.005 times 200 squared plus 2 times 200 plus 5. Okay. 200 squared is 40,000 times 0.005 gives me, and that's a negative there, so that's negative 200. Okay, plus 400 plus 5. So that gives me a positive 205 feet. So the height, y, is 205 feet. The distance, x, is 200 feet from its release. Okay. What is the horizontal distance the arrow travels before it hits the ground? Round your answer to the nearest foot. Okay, to solve this last part, part B, the horizontal distance the arrow travels before it hits the ground, basically what you're looking for is the zeros of the function. Okay, so basically the turns out to be a little bit of a pain in the butt because the numbers get so small, but we'll work with a different problem a little bit later. But remember, you're looking for y equals 0, so you are looking for the zeros of the function. And you know how to solve for the zeros by probably quadratic formula would be the best. And just to give you a goal, if you want to work this out, you should get 402.485 feet. Okay? Alright guys, good luck on your homework, and I will see you in class tomorrow.